Welcome to EducAgent Studio, where a crew of AI agents help us teach, and you learn with ease. Here's the problem we'll solve today. Here are our two column vectors, v and w, given in component form. We will compute the sum and difference, then draw them all from the origin, and also show head to tail and the parallelogram rule. Pause and think. Can you predict where v plus w will land? If not, you'll enjoy the moment when it clicks in the next beats. First, we compute the component-wise sum and difference, so we know the endpoints. We get v plus w equals 2, 3, and v minus w equals 6, -1. These are the endpoints we will plot from the origin. We'll use a plane that contains all our endpoints so the geometric relations are clear. We'll use this plane to plot the vectors and compare their endpoints and head-to-tail placements. We restate the vectors so the viewer keeps the components in mind before plotting. Here are v and w drawn from the origin. V goes to 4, 1, and w goes to -2, 2. Notice their directions and magnitudes as given by their components. We will add the vector v plus w in two equivalent ways to emphasize component-wise and geometric addition. The component computation gives the endpoint 2, 3. We will show that vector geometrically as well. Method A. The sum v plus w is the arrow from the origin to 2, 3, matching the component calculation. Method B. Placing a copy of w at the tip of v lands at the same point, 2, 3. Completing the parallelogram shows the diagonal from the origin is the same vector v plus w. We will represent v minus w both as a component vector from the origin and via v plus -w or tip-to-tip subtraction. The components give the endpoint 6, -1. We'll show this vector and two geometric interpretations. Method A. v minus w is the arrow from the origin to 6, -1, matching the component result. Method B. Adding -w at the tip of v arrives at 6, -1, showing v minus w equals v plus -w. Alternatively, the vector from the tip of w to the tip of v is the same as v minus w. This gives a tip-to-tip geometric interpretation of subtraction. Let's recap the endpoints and the geometric rules we used. All four arrows from the origin match these endpoints. We used component-wise addition, head-to-tail copies, and the parallelogram diagonal to see the same results. Great job following along. Watch the next video to learn more and keep the vector fun going.